And 1 by 4.
And 1 by 4. Okay. So moving to the next concentration term, which is very important, and that is basically molarity. And we denote it by capital M. And first of all, I'm going to write a very small definition of this to extract a formula from this definition, and we are going to define this. Molarity is basically number of moles of solute per unit volume of solution in liter, per unit volume of solution in liter. You are going to give, you are going to put the volume in liter always. If you are going to find the molarity, if you are need to calculate the molarity will be equal from this definition. We can write number of moles of solute upon volume of solution in liter. Okay. So this is the formula, and what is the unit of this molarity? Since in numerator we got moles and in denominator we have liter, so it will be moles per liter. Okay.
Okay.
And we generally denote by capital M. If we got 2 moles per liter, generally in the books or anywhere, we will be denoting it with 2M. And you will see 2M will be there, that means 2 molarity per 2 moles per liter.
Okay.
Solute in 1 liter of solution. Okay.
Okay.
Okay. So I'm going to change the slide and I'm going to give you some question from very easily. 49 gram H2SO4 present in 250 centimeter cube of solution. Calculate molarity.
What is sulfur's molecular mass like?
Sulfur is an atom, so its atomic mass is 32.
32. Okay.
Yeah.
What is the conversion of 250 centimeter cubic to liter?
See, do you know how to convert ml?
What?
ml into liter.
Yeah. 1 liter is 1000 ml.
1 liter 1000 ml. So in the same way, 1000 ml. So it will be 1000 centimeter. That means 1 ml is equal to 1 centimeter.
Oh, okay.
Should I explain it?
Wait, about to get. Is it 1.5 m?
Just let me check it. It's very easy.
Okay.
Okay. This is solution. We had a formula, number of moles of solute upon volume of solution in liters. Now you can see this is your solute. So I'm going to calculate the number of moles of solute, that is H2SO4. Given mass as 49. What we have? What is the molar mass of H2SO4 that you got?
Oh. No, I didn't get. I took 64. I thought like usually it's double of the atomic.
Oh,
I
so
know I
you just
130. I got 130. Yeah.
what you just said?
The molar molar mass of H2SO4 is 130.
No, no, it's wrong. It's 98. See,
98. Okay.
H2SO4. Hydrogen has atomic mass 1, and since 2 hydrogen is there, so I'm going to multiply it by 2. Plus, since we are going to move from one atom to another, there will be positive sign sum.
Yeah.
Sulfur is 1 atom and the atomic mass of sulfur is 32. Plus, moving to the next. So oxygen is 4 and one oxygen has atomic mass 16. So we need
Yeah.
to add 2 plus 32 plus 64. That will give you 98.
98.
Okay.
Okay. Okay.
So we will get 1 by 2 moles.
Yes.
So we get here 1 by 2. And what is the volume of solution? 250 centimeter cube. But we need to put it in liters. So divided by 1000.
1000.
So it will be cancelled by 4 times. So here we get 1 by 2 divided by 1 by 4. 4 will be in numerator, 2 will be in denominator, and we will get 2 m or 2 moles per liter. So please do write it. Let me know.
Yes. Yes. Yeah. Okay. Done.
Okay. So I'm going to give you again a very simple question, that is basically 4.6 gram of C2H5OH, that is ethanol. Do you know the formula of ethanol?
Yeah. Yes. Yes.
Oh, that's good. Present in 500 ml of solution. Calculate molarity.
Yeah. I got 0.2 molarity.
0.24 mole.
No, 0.2 molarity. That's it.
Okay. Just let me check it.
Okay.
Molarity is number of moles of solid upon volume of solution in liters. So number of moles of solid given mass upon molar mass, right? Molar mass you got 46 or not?
Yes. Yes.
And volume of solution in liter 500 upon 1000. So it will be 2 and this will be 10, right? So 1 by 10 divided by 1 by 2, 2 will be in numerator and 10 will be in denominator. Very good. You got the right answer. Okay. Calculate molarity of following. The question is very easy. 7.7 point, wait a minute. 7.1% weight by volume, Na2SO4. The second is basically 49% weight by weight, H2SO4, present in a solution, present in a solution of density 1.25 gram per ml. It's a very easy question. Can you do it?
Yeah. Yeah. Okay. I'll try. For sodium, what is the atomic mass?
It's 23.
23. Okay. Yeah.
Are you done with the first one?
Yeah. First one I got 0.05 molarity. Yeah.
0.05 molar. Okay, do the second one.
What?
Do the second part.
Yeah. Yeah. Yes.
Uh, what you got for the first one? 0.05, right?
Yeah. 0.05. everything.
Yes, correct. Are you done with this?
No, no, no. The finding volume.
Should I explain it?
Wait, wait.
See, 49% weight by weight, that means 49 gram
Yes,
of H2SO4 in 100 gram solution, right?
yes,
And it's also given that 1.25 gram per ml is the density of solution, right?
yeah,
And what we need to calculate is basically molarity, which has a formula number of moles of solute upon volume of solution in liter. Now see the
yes,
difference. Number of moles of solute we can calculate from here,
yeah,
but we need volume of solution in liter. That is not directly given, but we
yes,
can with the help of mass of solution and density of solution. Since we know the formula from our childhood, D is equal to M by B. So
yes.
V will be equal to volume of solution is equal to mass of solution upon density of solution. What is the mass of solution? 100 gram.
100.
Density of solution 1.25 gram per ml. So gram and gram will be cancelled, and it is basically 100 into 100 upon 125. Can I write it? If you are going to
Oh, okay.
remove the decimal, 100 will be in denominator and that 100 will be in numerator. Come to numerator.
Yes.
Yes or no?
Yeah, yeah.
And we will get 80 ml of solution. Now number of moles of solute 49 by 98. Volume of solution 80 by 100. Now we are gonna solve it 49 by 98 into
80 by
80
1000, right?
upon 1000. Yes, it is
Yeah.
1000.
Okay.
1000 upon 80. Thank you. That was my mistake.
Okay.
It will be cancelled by like this, and this is 100, which can be cancelled by 50 times, and you can cancel it by 4 times, and it will be I think, right?
Okay. 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 Yes. Yes.
How we're going to tackle the question. If you are going to write the complete information about the question, like what is given, and then what we need to calculate. Sometimes it will be directly given. If you are going to expand this, you can see it is directly given.
Yeah.
7.1 gram of Na2SO4 in 100 ml of solution. So it is given directly. But
Yes.
sometimes it is not directly given. In that case, you have to be careful. And from the given data, we have to calculate something.
Okay.
Done.
Yeah. Done.
Okay. So this is the direct question on molarity. Basically, there are questions like molarity on dilution. Do you know what is dilution?
Yeah. Like mixing with water, it becomes dilute.
Yes, basically addition of solvent. If you are going to add solvent, that is dilution. And in our day-to-day life, we dilute it by mixing water, right?
Yes.
So see, if we have a container, if you have a container and its container has a number of moles of solute N and molarity M1 and volume V. Now what you are going to do dilute it, yani, and that means basically you are going to add water or any solvent to dilute it.
Okay.
So will the molarity change or not? If you are going
Uh,
to add, yes,
yeah, volume will increase. So
molarity will change.
yeah,
Whether it is decrease, definitely it will decrease.
decrease.
So M2 and volume will also become V2.
Yes.
Volume will also change.
Yes.
But what about N? This N is basically number of moles of solute. This N is number of moles of solute. Can you tell me whether this number of moles of solute changes or not?
No, no, only solvent is changed.
Because solvent added, number
Yeah,
of moles of solvent increases, but number of moles of solute will be as it.
same.
Now
Yes.
I'm going to apply the molarity formula on the first container. M1 will be equal to N upon V1, and from here N will be equal to M1 V1. Can I write this?
Okay, okay. Yeah, yeah.
In the same way, second container, on the second container, I am going to apply the formula N upon V2, and number of moles of solute N will be equal to M2V2. Now you understand that this is the second equation. Before dilution this is, and after dilution, but in both cases number of moles of solute are same, Nn. That means from 1 into M1 V1 is equal to M2 V2.
Okay, okay. Yeah.
So whenever the questions on molarity will be like diluted, we are gonna use this. If you are going to again dilute it and make it in a keep it in a third container, that will be M1 V1 is equal to M2 V2 is equal to M3.
Yeah. Sir, lagging.
Am I
Voice is lagging.
lagging?
Yeah. Okay, yeah, now okay, now okay.
Okay, let me know if I'm lagging.
Okay.
Can you speak again? I'm just checking my.
Yeah, yeah.
I don't know why it's not working. It is connected but not working.
Uh,
Let me know when you are done with this.
yeah, about to. Yeah, yeah, done.
Okay, so we are going to have a question on this so that it will be in our
Yes.
mind. Just suppose 0.2 m HCl, comma 200 ml solution diluted with 50 ml water. Calculate the new molarity.
Yeah, 0.8 molarity.
So what you have
M1 V1
applied
and
is
V2.
what you are asking.
No, nothing. Not asking anything.
Okay.
Right.
Have you got the answer?
Yeah, yeah. It's zero point 0.8 molarity.
Can you tell me in fraction what you got?
Oh, 8 by 10, or it can be written as
8 by 10.
yeah, 8 by 10. Yeah,
Okay, just see.
or 4 by 5. Yeah.
This is M1, this is V1. Can you tell me what we need to calculate M2? Can you tell me the value of V2?
Yeah, 50 ml or
Not 50
50,
ml.
55,000. Yeah.
No, no, you see, uh, Davis, there is a container which has a volume 200 ml and
Yeah.
molarity 0.2 ml, and you
Okay.
are going to dilute it. Then in this container, what is the volume of the solution?
Oh, okay. Yeah, it's 250 ml. Yeah.
Yeah,
Okay.
generally students do mistakes here, so it's
Okay.
normal. So the volume will be 250, right?
Yeah, yeah, yeah.
And you don't need to convert it into liter. You know why? Because
Yeah,
here ml
cancels.
and here in ml, that both
Yeah,
will be cancelled,
cancel. Yeah.
right?
Yes. Yes.
So you can see 1010 will be cancelled, and this is basically 4 divided by 25, your answer.
Yes.
Yes or no?
Yes.
This much. Move to the next part.
Yeah, yeah. Okay, done.
Can we move to the next part?
Yes, yes.
So this was basically molarity on dilution. Now we are going to see the molarity of mixture. Molarity of mixture. So see what is molarity of mixture. It's very easy to understand. Basically, if you have a container, in the previous example we added only the solvent. This has a M1 molarity volume V1 and N1 number of moles of solute, and we have another container which has number of moles of solute N2 and molarity M2 and volume V. Now we are going to put these two solution in a single bigger container which has number of moles of N, solute and volume molarity M and volume V. Is that clear?
Okay. Yeah.
Can you tell me the value of number of moles of solute in the bigger container? Isn't it N1 plus N2?
Yeah, 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 yes.
And can you also tell me that volume of solution in the bigger container will be equal to V1 plus V2?
Yes, yes, yeah. It will be vegan.
It's very easy to understand, right?
Yeah.
Now moving to this container, I'm going to write M1 is equal to N1 upon V1. So can I write N1 will be equal to M1 V1? Can I write this?
Yeah, yeah.
In the same way, can I write for this container N2 will be equal to M2 V2?
Yes.
In the same way, can I write N is equal to MV for this container?
Yeah.
And as we know that N is equal to N1 plus N. So what I know, at the place of N, can I write MV? At the place of N1, can I write M1 V1? At the place
Yes.
of N, can I write M2 V2? And here, the resultant molarity in the bigger container M, we will get a formula M1 V1 plus M2 V2 upon V. And we also know that this V will be equal to V1 plus V2.
Oh, okay. Yes.
So whenever there will be question, calculate the resultant molarity of mixture. You are going to do it, and you are going to solve it from this formula,
Okay.
right?
Yes. Yeah, okay, done.
Very good. I'm going to give you a question. Please do solve it.
Okay. Sir, is it 0.25 ml HCl or 0.25 m?
Yeah, it is 0.25 m.
M, okay.
Yes, it's m.
Okay. Yeah, yeah.
Let me know if you got your answer.
Yeah, yeah. Wait. Yeah, I got as like 112.5 by 350.
Okay. So molarity is basically you are
Yeah.
going to mix it. This is M1, this is V1, this is M2, and this is V2, right?
Yeah.
0.5 into 100 plus 0.25 into 250. And then you have 100 plus 250, that will be 350, right?
Yes.
And you can also see this will be 50
Yeah.
plus this will be basically 0, 0. Okay, 25, 6.25, 62.5, right?
Yes. Yes.
And then there will be 350. And then if you're going to add it, it is zero point 0.5 and then 2 and 5, 6, 11 upon 350, right?
Yeah. Yeah. That's the answer.
Okay. Now I'm going to give you another question on the same. That is
Okay.
basically 1 molarity, comma, 2.5 liters NaOH solution is mixed with another 0.5 m 3 liter NaOH solution. Then calculate the molarity of resultant solution. This same topic, concentration term, is in your class 11th first chapter of chemistry. So we are going to do there a lot of questions that will cover that portion also.
Okay.
We will not be in need of covering that topic there.
Yeah.
Please let me know the answer.
Yes. Wait. Yeah, I got 8 by 11 molarity.
What's your answer?
8 by 11.
8 by 11. Okay. Wait a minute. It's 0.73, right?
Let me see.
Yeah, it is good. Can we
Yeah, like
move to the next
0.75.
part?
Yes. Yeah.
Now we are going to see how to calculate molarity of ions. Molarity does not have only question on their formula, but there are different types of questions on molarity, like molarity on dilution, molarity of mixture, and then we are going to talk about molarity of ions. And there we already discussed the basic questions on molarity formula. So we
Okay.
have molarity of ions. So this topic will be covered with the help of an example. Just suppose if you have given 4.9% weight by volume H2SO4, okay, and we
Okay.
need to calculate molarity of molarity of. The first one is H2SO4 that you can calculate, and B is H plus that I will explain, and SO4 minus 2 that I will explain. Okay, so I
Okay.
want you to calculate the molarity of H2SO4 with the help of given
Okay.
question. It's very easy. Are you done with this?
Yeah, about to be. Once again, last. Yeah, 0.5. Yeah, 0.5 molar.
Is it 0.5? Okay. Just
Yeah.
let me check it. Number of moles of solute, that will be 4.9 upon 98. Upon volume of solution, 100 upon 1000. That will be approximately 1 by 20. And then 1000, that means 10. So it will be 0.5, right?
Yes. Yeah.
Can you dissociate this H2SO4? As you know that H2SO4 is a strong electrolyte. Can you
Yeah.
dissociate this? Do you know how to dissociate it?
Yeah, H plus, two H plus and one SO4 minus. Yeah,
and SO4 minus 2. Whenever
yeah, two
you are
minus.
whenever you are going to dissociate, just make sure whether it is balanced or not.
Okay.
Atomic, you can say two hydrogen, one sulfur, four oxygen, four oxygen.
Yes.
After checking the atom, check the charge also. Zero charge on the left hand side, that means zero charge should be on the right hand side.
Yeah.
Total charge minus 2, and one hydrogen has plus 1, two hydrogen will have plus 2. Overall charge 0 on the right hand side also, right?
Yeah. Yes.
Now we are going to use stoichiometry from class 11. Since you are a maths student, you know what is coefficient means in maths,
Yeah.
right?
Yes. Yes.
So in chemistry, we call it stoichiometric coefficient.
Yeah. Yeah.
If I'm going to ask you, what is the stoichiometric coefficient of H2SO4?
One.
1. What is the stoichiometric coefficient of H plus?
Yeah. Two.
Stoichiometric coefficient of SO4
One.
minus 1. So first of all, we are going to compare it. 1 mole giving you 2 mole and 1 mole giving you 1 mole. In the same way, you can compare molarity. 1 molarity of this will give you 2 molarity of this, and 1 molarity of this will give you 1 molarity of this. Is that correct?
Yes. Yes.
Now see, this is what is the molarity that we actually calculated 0.5.
Yes.
1 is giving 2, that means 0.5 will give 1 m.
One.
1 is giving 1, that means 0.5 will give 0.5.
0.5.
It's so easy. If you're, it's very easy to calculate this. What is the molarity of this H2SO4? And if you are good in dissociating the molecules like this in ion
Yeah.
form and balance them, and then just compare it like unitary method from 1 to 2, 2 to 3, like this.
Yeah. Yeah. Yes. Yes.
Please do that.
Okay. Yeah. Done. Yeah.
So I'm going to give you a question. Question is basically, wait a minute, not 71. We already did this.
Okay.
You know what is the beauty of this question? If it will direct ask you what is the molarity of Na plus H plus CO3 minus 2, you have to calculate the molarity of NaHCO3. Then you can go on Na plus H plus CO3
Yeah.
minus 2,
Yeah.
right? So
Yes.
please do
Yeah.
it. I will be back with my water.
Okay.
Please let me know when you are done with this.
Yeah. Wait. Yeah, all are 0.04 molarity.
0.04.
Molarity.
Just let me check. 0.84 divided by 84 divided by 50. The equation you got earlier.
Wait, sir is lagging.
Am I lagging now?
Yeah. Yes. Yes, sir got disconnected.
Okay. Am I? Is my voice clearly audible?
Yes. Yeah.
So you got this equation right?
Wait. Yes. Yeah.
So it will be I think 0.04, right?
Yeah. 0.04. Yeah.
0.04 you told me. I thought 0.4.
No.
So
0.0.
yes, if you are going to delete it and balance it, you will see one molarity of this, one molarity of this, one molarity of this, one molarity of this. And since it has 0.4
Sir
m,
is like the
so
board is lagging.
0.04 m. Is my voice lagging again?
No,
Wait a
voice is
minute.
okay,
Just
but
let
the
me.
board is like lagging behind.
Davis, this screen is lagging.
Yes. I mean now okay.
Okay.
Yeah.
So all will have 0.04 m, right?
Yes.
So please do write it. Then move to the next part.
Yeah. Done.
Now I'm going to give you another type of question of molarity that generally asks. Calculate mass of NaOH presenting semi-molar solution of semi-molar solution of volume 250 ml. Please do this.
Okay. Semi-molar solution means
So there are some terms that we are sure aware of, like semi. Do you know what is semicircle?
yeah, half a circle. Yeah.
Half. That means semi-molar. That means half m given. That means
Oh,
0.5 m given.
okay.
Very easy. Okay. Now
Yeah.
you can.
Yes. Yeah, mass is 4 gram.
4 gram. Just let me check it.
Okay.
Molarity as a formula, number of moles of solute upon volume of solvent, right?
Yeah.
So this has 1 by 2 number of moles of solute, that has a value 250 ml. So 250 will be here and 1000 will be multiplied in here, right?
Yeah. Yeah.
So basically number of moles of solute is basically 1 by 8, right?
Yeah. Yeah.
Given mass upon molar mass. Do you know what is the molar mass of NaOH?
Yeah. 40.
So the mass is 5 gram, right?
Yes. Oh wait.
You got this.
Wait. Okay. Yeah. Actually, yeah. It's 5 gram. Yes, it's 5 gram.
Can I move to the next part?
Yes. Yes.
Okay. Now see, first we are going to talk about normality first, and then we will talk about molality. So first of all, before starting normality, it's very important to talk, that is equivalent weight, and number of gram equivalent. See, this we can call it equivalent weight either or equivalent mass. So there are two terms that we need to cover before starting normality. So I'm going to start this equivalent weight, and
Okay.
it is basically equivalent weight you can call, or equivalent mass. And
Okay.
it has a formula. Equivalent mass or weight is equal to basically molar mass upon x. And I think you can easily calculate the molar mass of any compound,
Yeah.
right? If the compound, the elements present in compound is from D block element, the questions in the question the atomic mass will be given generally. Okay,
Okay.
so you can calculate molar mass. What about this x? What is this x? This x is very important, and this x is known as either as n factor, and or we also call it valency factor. And we will discuss about this. What is this n? Sorry, x.
Okay.
So first you are going to write this formula and then let me know. I'm going to make a chart of this x and we will discuss about this. Very easy.
Okay. Okay.
Should I start?
1 minute. Yeah. Done.
Okay. Yeah.
Yeah. Done.
Okay. So let's say what is this x? See how we are going to calculate x for different compounds. Can you recognize whether that we are going to calculate for? That means the compound is acidic, basic, or salt. Can you recognize whether it is
Uh,
acid, base, or salt?
yeah. Based on looking. Yeah. Some of them. Yeah. Some of them.
Some of them you can easily recognize,
Yeah.
right?
Yeah.
And if you are not going to recognize, I will give you another trick to calculate the value of x.
Okay.
Okay, so first of all, if it is an acid, if it is it is a base, and if it is a salt. So see, it's so simple that you are going to recognize this. If it is an acid like HCl, just tell me how
Yeah.
many H plus it will give.
1. 1.
1. That means basically x is equal to number of H plus given.
Oh. Okay. Okay.
Are you getting my point?
Yes. Yes.
So this is HCl and HCl will give H plus. That means if you are going to calculate equivalent weight of HCl molar mass, that will be 37.5 divided by x, that means 1.
Oh. Okay.
And if you are going to calculate equivalent weight of H2SO4, you know the molar mass of H2SO4 is 98, and since it will give 2H plus, so X is,
Oh. Yes.
it's very easy.
Yeah. Yeah.
Now see, what is base? For base, X is equal to number of OH minus given. So if I'm going to ask you equivalent weight of NaOH, what it will be? 40 by 1, because it will
40
give
by
OH, 1 OH minus.
yes.
Equivalent weight of MgOH whole twice. Can you tell
Yeah.
me? It will be the molar
Mg
mass
is
of
20.
MgOH whole twice divided by
Yeah. 2.
what?
Yeah.
Now see what is salt. If you have given salt like NaCl, or if you have given NaHCO3, that you will say that sir it is an acid because it is giving H plus. Yes, but it is not an acid. We can call it acidic salt. Are you getting my point?
Okay. Okay. Acidic salt.
CaCO3,
Okay.
what is CaCO3? Salt. Just take it as salt.
Yeah.
Na2CO3, just take it as salt. Na2SO4, just take it as salt. Are you getting
Yes.
my point?
Yeah. Yeah.
Now, in order to calculate the value of X in salt, X will be either total number of positive charge, total positive charge, total positive charge, total positive charge. Either you can take total positive charge, either you can take total negative charge.
Okay.
Because since you can see this is salt, neutral compound, total positive charge will be always equal to total negative charge. And we only deal with magnitude, not sign. Are you getting my point?
Yeah. Yeah. Yeah.
Just take an example like NaCl and how we are going to see the charge. If you are going to dissociate, only then you can see the charge. And if you are going to calculate the equivalent weight of this NaCl, molar mass of this 58.5 upon, either you can take the positive charge, either you can take the negative charge. So the value of X will be 1.
1. Okay.
If you are going to calculate the equivalent weight of NaHCO3, you have already dissociated it. Molar mass of NaHCO3 divided by, you know that this will be converted into Na plus
1.
H plus and CO3 minus 2,
Yeah.
not 1.
Oh,
Total
okay.
positive charge is 2. Total negative charge is 2.
2.
So it will
Okay.
be divided by. Are you
Okay. Got
getting
it.
my point?
Yeah. Got it.
So equivalent weight has a formula, that is molar mass, that we can calculate divided by X, and X can be calculated like this. And if you are not able to think that whether it is acid or base, just follow this total positive or negative charge. Okay.
Okay.
In redox reaction, we will deal with N factor, then it will also be clear.
Okay.
And this X also depends upon the reaction. Like if I'm going to ask you a question like this, just tell me. If I'm going to ask you a question from this reaction, calculate the value of X, N factor or valency factor of H2SO4. What will be the value of X? Can you tell me?
Well, 2H plus it will give. So, yeah, 2. X
X is equal to
2.
for this reaction.
Yeah, yeah. Oh, sorry.
For this,
Yeah, it will be H2SO4 is 2 plus 32 plus.
no, you are not getting my point.
Okay.
I asked you that for this reaction, H2SO4 is equal to H plus and HSO4 minus. Can you tell me the value of X, valence
Oh,
factor or N factor?
it should be 2H plus, right? If you balance it.
Okay. See what I have written here. X is equal to number of H plus given.
Yes.
In this reaction, how many H plus is given by H2SO4?
1. Yeah.
So X is equal to. So be careful about this. Right?
Okay.
Because this
Okay.
H plus that we write in theoretical H2SO4 to H plus SO4 minus, it does not go like that. You have studied it in ionic equilibrium. It goes stepwise.
Okay.
Actually, I want to tell you a concept. I want to explain a concept that this is H2SO4 and this will be converted into H plus and then HSO4 minus. And this is acid dissociation constant Ka1. Again, this HSO4 minus will be converted into H plus and then SO4 minus, and this is Ka2. Now see, do you know what does this K1 and K2 says? What
No,
does
no,
this? This is
no.
acid dissociation constant, right?
Okay.
Dissociation constant. And you know what? If acid dissociation constant is higher, that means acidic character is very high. It is more acidic, a strong acid.
Okay. Yeah.
So can you tell
Okay.
me, if I just give you a concept about the acidity, that K1 increase, Ka acid dissociation constant increases, acidic character increases. Which one is more acidic? This first one is plus, or in the second step is plus? What do you think? Which one
Uh,
is more acidic? There can be question like this. Uh, yeah, you can think like this. My question is that which is more acidic, this or this? Or the question can be which one is greater? The greater dissociation constant will be more acidic, right?
yeah, yeah, yes, yes.
Or you can think like the compound which gives H plus easily,
Ah, the first
that will
one.
be more acidic.
Yeah, yeah.
So what do you think? This will
The,
give easily or this will give
the
easily?
first one will give easily because it is like more stable.
Okay,
I,
you
I
just
guess.
said the first one is give easily
Yeah,
or
easily.
faster than the second one, right?
Yeah, yeah. I think yes.
Why second one will not give easily?
Because it has negative charge and
Yes,
already
negative
slightly.
charge, and if you want to take positive charge from here, it will attract this. So it
Yes,
will
yes,
very good, very good.
yeah.
It's good. So please do write this concept. Next.
Okay. Yeah, yeah.
Oh, wait a minute. Thank you. Thank you.
Yeah, scroll down a little bit.
Are you-
Yeah, this one I did. Yeah.
Okay. So can we move to the next part?
Wait, a little bit about that part. Yeah, this one.
Okay.
Yeah.
This we will talk. This we will study in ionic equilibrium.
Okay, okay. So there we went. Okay, okay. I'll just quickly note down.
Okay, okay, no problem. Just note it. Whatever you want.
Yeah, okay, done.
Very good. Now see, if I'm going to ask you calculate equivalent weight of following, you need to calculate it. HNO3 base KOH C is H3PO4 D is H3PO3 E is H3PO2. Anything else? Okay. H2SO4, not H2SO4, we just calculated CaCO3. Please do this.
Okay.
And I think, wait a minute, I think you can calculate the molar mass, right?
For phosphorus, I don't know. And
Molar mass of
potassium.
anything you can calculate, molar mass of any compound, of this compound at least. You can
No,
calculate,
no,
right?
for potassium, phosphorus, and calcium, I don't know.
Okay. So you have to be careful. You should learn up to 20. Potassium
Learn
is
up 20.
39, calcium is 40, and phosphorus is 30. Okay.
Okay.
Have you done with this?
Wait, like two more to go. Yeah, okay, done. Yeah,
Very good.
okay. First one is 63. Yeah.
What is
Second
it?
one is 56. Third one is 98 by 3.
Is it 98? Wait, let me check it out first.
Okay.
31. Wait a minute. Uh, just wait a minute. 31, right? 31 and 3, 4. 30.
Yes.
31 plus 3, 34.
Yeah, plus 98. Sorry, 64.
64. That's good. 98. Okay. The third one?
So yeah, the fourth one is yeah, 82 by 3, which is 27.34.
Okay. Molar mass upon what is the value of X here?
X is 3. Yeah.
Oh, okay. What is
Then
the
E is
value of X here?
yeah 3.
And what is the value of x here?
2.
You know what? The value of x here, correct, 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 incorrect, incorrect.
Oh, okay.
So see, basically, this goes only because you see 3x, and that's why it will give
Uh,
3x plus, right? But the concept does not go like this. If you are going to draw the structure of H3, PO4, H3, PO3, and PO2, wait a minute, please.
okay, yeah, no problem.
So see, this is the structure of
Okay.
H2O. You have, do you know how to write the structure of inorganic compounds? You have studied it in chemical bonding class. You
Yeah,
have, I think.
most like normal compounds, like I can do this one, this type,
Okay.
don't.
We will see how to calculate the structure. It's very easy. Okay.
Okay, okay.
Now see the 2 days concept. What I was talking about. You know that
Yeah.
this is delta negative. This is delta
Yes.
positive. Do you know
Yeah.
why I am writing this?
For dipole, is that one?
Yes,
Okay.
oxygen is more electronegative than hydrogen, so it will attract hydrogen's electron. That's why there will be delta negative, then delta positive, right?
Yes. Yeah.
Do you know what is the criteria for solubility? It is basically basic principle like dissolves, like. That means a dipole solute or a polar solute will be dissolvable or soluble in a polar solvent. Are you getting my point?
Okay, okay. Yeah.
Now see what happened. We have H2O as a solvent. So this is also a polar solvent. Polar solvent, not apolar, non-polar. This is I am telling you polar solvent, right?
Okay.
So if
Yeah.
you are going to dip this in water, this will be broken and it will be easily dissolved, right?
Oh, okay. Yeah. Yeah.
Now come to this. Yes. Come to this. This will be delta negative, delta positive, delta negative, delta positive. And this can be easily breakable. This is easily breakable or dissociable. But phosphorus and hydrogen does not have that much electron negativity difference. And it's not that much polar that it will be dissociable. That's why
Okay.
this hydrogen does not dissociate, and this H3PO3 gives us only 2H plus.
Okay. 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 Got it. Yeah.
Okay, in the same way, you can go for this. So H3PO2 only give 1H plus. That's why X has a value 1 in H3PO2, X has a value 2 in H3PO3, and X has a value 3 in H3PO4. This is phosphorus and phosphenic acid. So we will discuss about in the law. Please do.
Okay.
Let me know when you're done with this.
Yeah. 1 second.
Next class will be on Wednesday, right?
Yes, yes.
Okay. On Wednesday, I will little bit extend the class for 5 to 10 minutes. As
Okay.
today I have to go for dinner because after this the shop or restaurants will be closed. Are you done with this?
Yeah, yeah, okay, done. Yeah. And that,
Okay. Okay, I'm just going to. This is about equivalent weight, and
yeah.
then the next topic comes, that is number of gram equivalent. Just like number of moles. Number of
Okay.
gram equivalent has a formula, given mass upon it is not molar mass, it is equivalent mass.
Okay.
So you have to calculate equivalent mass because we have a formula for equivalent mass, that is molar mass upon X. Sometimes equivalent mass will be equal to molar mass in case of valence factor equals to 1, and sometimes it will be lesser, right?
Okay. Yes.
So please do write it from this here. We'll be continuing in the next class on
Okay.
Wednesday. And we please do